Okay, so let's continue our sample problems. So our next second problem is shown on the screen, and let's read. At the instant that theta is 45 degrees, the athlete is running with a constant speed of 2 meters per second. Determine the angular velocity at which the camera must turn in order to follow the motion. So really the problem is there is an athlete that is running sa field, and then there is this camera that is following the athlete. So makita to sa figure ng camera, yung origin is at point A, so yung positive direction is counterclockwise, and the distance of the runner from the camera is 30 meters in vertical direction. So ang ginapakita is angular velocity, which is the theta dot. So how do we solve this one? Let's try. So this one, touch. So first, let's draw down isang figure. We have R, we have runner, we have A. So, anong angle? Wala ang angle na. May angle na given. Wala pa. 30 meters lang dito. May angle na 20. So, arbitrarily yung natin na this is 1.62, I guess. Yes. And this is our given. This is R. This is our runner. This is the camera. This is our positive angle. It's point A, and the distance is 30 meters. Okay. So, butang sa X to complete the figure. So, the question is ang theta. Ang theta that ginamita. Required is theta. So, how do we solve this problem? Let's try that using geometric relation, using the formula from trigonometry, if we can find something. The 30 meter is constant. So if we use sine, sine theta equals to 30 over r, and then r sine theta equals 30, and let's derive this one, r theta sine theta plus derivative of sine theta is cosine theta times cos theta that cos theta that times ang sa wala, which is r, which is 0. Derivative of the first times the second, and derivative of the second times the first. R that times sine theta, and then derivative of sine theta is derivative of the theta times the cosine theta times, of course, the left term, which is r. So we have theta dot here, we have r, we have sine and cosine of the angle, and the r dot. Oh, given yung 45 tingala mo ito. So no problem na sa sine theta, sa cosine theta, sa r at that point, because that is 45, ng 30-30, so 2. What about the r dot? Okay. Let's analyze one using polar coordinate system using components. As we can see here, some velocity. Velocity of the runner is the resultant velocity. If we dissolve this into components, this is the V theta and this is the VR, correct? And if this is 45 degrees, therefore this is also 45. This is also 45. Okay. So now, makuha ta ng VR, makuha ta ng V theta. VR is equals to V theta because 45 ang aton nga angle, 45 by 45. This is equals to V divided by square root of 2. These are special triangles. So no basic lang natin na transition from leg to hypotenuse. V square root 2. This is also R dot. So we can plug the V is 2 meter per second. Okay. So this is 2 meter per second divided by square root of 2 times sine 45, which is square root over 2. That's cos 45 theta dot, and we put that. Ang R is equals 30 square root of 2 plus 0. Let's simplify. This is 2 square root of 2. Sine 45 is square root over 2. Plus cosine 45 square root over 2. And then 30 square root of 2. And theta dot equals to 0. Therefore, our theta dot is equals to 1 over 30. 1 over 30 radian per second, or negative 0.01. Please try to check if the solution is correct. So that's the instantaneous angular velocity of the camera at that instant, meaning at the instance that the radius is 30 square root of 2, or at the instance that the angle is 45 degrees. Amo na dapat ang speed ng camera in order to follow the athlete. Okay, so let's proceed with the third problem.